In this video, we'll go over ratios and proportions. We'll talk about the definitions of both, and then we'll also roll through some examples of each. Now, first of all, let's define what a ratio actually is. And really, it's just comparing two different values. So in this situation here, I'm using the variables a and b. If I write a fraction, a over b, that's the ratio of a to b. And you could write it a couple ways like this right here. So if I were to substitute numbers in for that, this would be the ratio of 3 to 4. Or if I wanted to come up with some sort of like real world example, say if I had a bag of baseballs and a bag of footballs, in my bag we could see for every 3 baseballs I have, we also have 4 footballs. So if I wanted to put more baseballs in the bag, so say like I wanted to put 6 baseballs in, that means that I doubled my amount of baseballs from 3 to 6. So then I have to double the amount of footballs from 4 to 8, and that would make sure that the ratio is still true here. Now there's also something called an extended ratio, and that just means that we have 3 or more quantities. So we could use this example that I used up here down here. Let's say I have 6 to 8 again, right? So this means 6 baseballs and then 8 footballs in one bag. Well, maybe I included a bunch of frisbees and I said, alright, well, then I have 10 frisbees in this bag as well. And this is my new ratio. Well, that's all good if I wanted to double the amount of baseballs now. So if I made that 12, then that means I also again have to double the footballs. So that becomes 16 footballs. And then I have to double the amount of frisbees. So that becomes 20 frisbees. So that's pretty much what ratios are all about right there. Now you also have to consider proportions, and proportions are just when you have two different ratios. Well, actually they're the same. They look different, but they're equivalent to each other. So we have 2 to 3 here, which is equal to 4 to 6. Well, 2 to 3 is the same as 4 to 6 because it's just reduced. If you had 4 to 6 and you divided both by 2, then you'd have 2 to 3. So that would be equivalent up here. It's just like the same example as back here when we had the baseballs and footballs. Well, we have 3 to 4 right here, 3 baseballs to 4 footballs. Well, it's the same thing as having 6 baseballs to 8 footballs. They're equivalent. We have more of all of them here, but that ratio is still equivalent. Now that you know what a proportion is, there's going to be situations where we have to find a missing variable when there's a proportion in front of us. So in this case, we have 7 over x equals 56 divided by 72. So we got to get this x by itself. To do that, I want to get it out of the denominator. So I'm going to multiply this left side by x. Means I have to multiply this right side by x as well. Now, x over x is just 1, so that cancels out. I also have to get rid of this 72, so I multiply the top part by 72. That means I got to multiply this part by 72. And then 72 over this 72 is just 1, so it goes away. And now I'm left with 72 times 7, which is 504. And that equals 56 times x. Now I want to divide by 56. That gets that away. 504 divided by 56 is 9. Okay, so 7 over 9 is equal to 56 over 72. This is also, you could also do cross multiplication if you ever heard of that. That's when you would take 56 and multiply by x, and then you take 7 and multiply it by 72, and then you get your new equation there, and then you could solve from that. But this is the normal way that I like to do. Over here we have another proportion, but this one we have two different, not two different variables, but the unknown variable is written twice. But we do it the same way as we did over here. First, we got to get rid of this y over 4 from the denominator. So I multiply the top part by the quantity of y plus 4. That goes away. That means I do this side by it too, multiply it by y plus 4. And then this right side, I want to get rid of the 3 on the bottom, so I multiply the top part by 3. So 3 over 3 is 1, it goes away. So I multiplied that side by 3. Now we've got 3 times y and 3 times negative 5. That gives us 3y minus 15. And then we also have 2 times y right there, just 2y, and then 2 times 4, which is 8. Alright, this is a little bit easier to solve now, so I want to get my y's on one side. That means I'm subtracting 2y from here, that goes away, 2y from here as well. I'm left with y minus 15 equals 8. And then again, I want to get my y by itself, so I add 15 to both sides. And then that gives me y equals 23. That's because that goes away. And there's my answer. Lastly, I'll go over 2 more examples that covers ratios and proportions. So in this first one, we're given that 18a equals 24b. So 2 different variables. We want to find the ratio of a to b. What I recommend doing is, well, we know that a to b can also be written as a over b, like that, right? So if we could solve this equation right here and make it look like this, then we're good to go. So let's just get rid of this 18 right here first. So I'm going to divide this left side by an 18, divide this right side by an 18. That goes away. I'm left with this right here. Now I want to get rid of this b, so I divide this right side by b. B over b goes away. Now I got to divide this left side by b. And that's exactly what we wanted, because now we have a over b, and that equals 24 over 18. That reduces to be 4 over 3, because you could divide 24 and 18 both by 6. 24 divided by 6 is 4. 18 divided by 6 is 3. So you have a ratio of 4 over 3, or you could say also 4 to 3. Now in this question down here, we don't have any proportions set up, so we have to set that up first. It says Ronnie sells 10 containers for $7. So right away what I could do is actually write 10 containers per every $7. And that's going to be equal to something. So it says how many containers will he have to sell to make $21? Well, first of all, we know that 10 is the container, 7 is the dollar. So if we put down here the amount of dollars that he wants, well, on the numerator, that's the unknown number of containers that he has to sell. If we have 10 over 7, that equals x over 21. These ratios are going to still be the same. We could actually solve for that x. In this situation, I'll actually go ahead and cross multiply. I'll do 7 times x, and I'll do 10 times 21. That gives me 210, which is equal to 7x. To solve for x, then I have to divide both sides by 7. I'm left with x equaling 30. Now that leaves us with 2 ratios. 10 to 7, meaning he has to sell 10 containers to make $7, and then also we found out that he has to sell 30 containers to make $21. And that's about it.